It's time to talk about decorators, another key term in Python. And we've actually seen decorators before. Do you remember when we were building classes? I taught you that there was a class method and a static method. And I said, hey, don't worry about this. We'll talk about this later. Well, this is now later. Decorators look like this. They have the @ sign and then some sort of name following it. But in order for us to fully understand what decorators are, we have to talk about functions in Python and why they're so powerful. This is the neat thing about Python. In Python, functions are what we call first-class citizens. That is, they can be passed around like variables. They can be an argument inside of a function. They act just like, well, variables. Let me show you. If I create a hello function, which frankly is completely useless because all it does is say hello. If I do this, remember what I said. Functions are pretty much just variables in Python. Again, something that is not always the case with all programming languages. So if I wanted to, I can say greet equals to hello. So that if I print greet and I run this, I get hello. What if I just pass hello like this? If I run this, well, I get the function location in memory. So I would have to use greet like this and run it, right? We have to call the hello function. Okay, what if we do this? What if I say delete hello, a keyword in Python that deletes that function? What do you think will happen? Let's see. If I run this, is that what you expected? Did you expect greet to still work? The interesting thing about Python is that I create hello, and this is now created in memory. When we get to line 4, I say, hey, greet is going to point to hello. So hello can still be called down here. I can still say hello because hello is the name of the function that points to that location in memory. But when I do delete hello, all it does is say, hey, I'm going to delete this function, this name reference to this function that's in memory. However, because greet, a whole nother variable, is still pointing to this function, I'm going to delete the hello word. So if I go hello like this, I'm going to get an error. Name hello is not defined. However, the greet is still pointing in memory to this location. So Python is smart enough to say, hey, you told me to delete hello. I'll delete the name hello, but I'm not going to delete the function because greet is still pointing to it. So functions in Python act just like variables do. They're first-class citizens. We can also pass functions around inside of arguments, right? If I say hello, and then this hello receives another function that calls, let's say, function, like this, well, I can create a greet function. Let's say define greet. And this function is just going to print still here. Now, in here, if I call hello with greet, or just so we're clear, let's just say A equals to hello greet. And if I print A, what will happen? That still works. Because what happens is I say, hey, call the function hello. Okay, I'm calling the function hello with the argument greet. So we go here and we say, hey, run function. And what's function? we want to call this function, right? Because we have these brackets. So we jump to what function is, which in our case is greet. So we go over here and say, hey, just print this. We didn't have to call it in here because the hello function calls it for us. So why did I just teach you all of that? What does that have to do with decorators? Decorators are only possible because of these features. This ability of functions to act like variables, act like first-class citizens in Python. And when we start learning about decorators, underneath the hood, they're using this power of functions. Now, in the upcoming videos, we're going to talk about how to create our own, what they mean, and expand on this idea of a decorator. But here's a short form of what decorators do. Decorators supercharge our function. If we had our, let's say, hello function here, by adding some sort of a decorator, like this, we can supercharge our function and add extra functionality to it. It lets the Python interpreter know, I want this hello function to have some extra features. But let's explore this topic a little bit more in the next video. Promise to not get mad at me, but there's actually one other thing I forgot to mention before we can talk about decorators. I know I'm building the suspense. I know you're just thinking, hey, Andre, tell me what a decorator is. You're wasting my time. But one more thing, quick video, I promise. We have to understand this idea of a higher order function. That is a higher order function, or HOC for short. Sounds super important, right? A higher order function can be one of two things. It could either be a function, let's say the greet function, that accepts another function. So this right here is a higher order function. It's a function that accepts inside of its parameters another function. Another way it can be a higher order function is if it's a function that returns another function. If we define, let's say, greet2 that just runs normally, but instead returns another function. So let's say in here we have define func. And this define func, let's say, just returns 5. And we return the function. This is a higher order function. A higher order function is any function that either accepts a function as a parameter or returns a function. And if you're thinking, hey, is that map function that we talked about, is that a higher order function because it accepts a function? Yep, that's a higher order function. So is reduce or filter. These are all higher order functions. All right, I promise in the next video, we're going to talk about why this is important and what decorators are. I'll see you in that one. Bye-bye. Let's finally write our own decorator. Remember, a decorator supercharges our function. It's simply a function that wraps another function and enhances it or changes it. But the best way for me to explain what it is to actually code our own. So let's do that. Let's define a my decorator. And this decorator is going to accept a function. Right away, we should know that this is a higher order function. Now in here, inside of here, we're going to call the function. But before we do that, we're actually going to wrap this function in another function. So we're going to say define the wrap function. So this is just a wrapper. And this wrap function is going to be a function that simply runs this func. And then finally, we'll just return wrap function. And notice here that I'm not calling it. I'm just returning it so that later on somebody can use it. Okay, now let's say we have a simple function, hello. And this simple function just prints hello. What a useless function. Now, why is this useful? Because now I can use this as decorator. Python, as soon as we write an A in front of this, is going to say, hey, this is going to be a decorator. And the decorator, as long as we follow this syntax of accepting a function, having a wrapper function, calling the function, and returning the wrapper function, can be used. So if I do my decorator, see how it's all blue? Now, this decorator can actually be used on top when defining our functions. So if we want to use my decorator on the hello function, we use it like this. So that when I call hello next in my program, I click run, I get hello. Okay, I know what you're thinking. You're thinking, this is a complete waste of time, Andre. Why did I have to do all of that? I could have just done this, just define the hello, and that was it. I'm so confused. Well, here's the thing. What we just did with the decorator hasn't changed anything. It works exactly as expected. But what it allows us to do is that now we can add extra functionality. Remember how I said that decorators is a function, like my decorator, that wraps, that is here, another function, which is the function that we pass it, and enhances it. So how can we enhance hello? Well, we can do anything inside of this wrapped function. For example, I can say print, and then we'll just print some stars in here. And maybe print another set of stars in here. So that when I call run, boom, we've just super boosted our hello function. How cool is that? And this is why decorators are useful. By just adding this one line, I'm able to super boost a function. So that, let's say I create another function called buy. And this buy is going to print, see ya later. By calling buy here and clicking run, well, nothing changes. But if I wanted to super boost it, just like the hello, all I need to do is just copy the decorator and use it here as well. So that if I run it, there we go. We've super boosted our buy. This is the power of decorators. By just using this syntax, I can add extra functionality to other functions. Now I know what you're thinking. And I know I also keep saying that a lot. It's like I can read minds. But you're thinking, this is a lot of magic. How does Python interpreter do all of this? It seems like, well, magic, right? Underneath the hood, all it does, well, let me show you. Based on what we've learned so far about functions, because they're first-class citizens, right? All we're doing is literally this. We're saying variable A equals hello, and wrapping this hello and calling it with my decorator. So I'm saying my decorator, hello. And then after that, I am running A like this. So let's say this was hello 2. Well, I'm just running it like so. So that if I run this, everything still works. All I'm doing is wrapping my hello function with my decorator and assigning it to a variable. So if we go step by step, we see that my decorator receives a function, in our case, the hello function. It then returns this wrapped function that has hello in here. So we return this wrap function. So hello2 now equals this wrapped function. And then this wrapped function gets called. And what does it get called with? Well, it prints this, then it runs the hello function, and then it prints this. It's the same as doing something like this. We simply call it again. If I run this, it works. That looks strange, doesn't it? But it should make sense. We're calling the first function, and the first function returns another function, and then we call the next returned function, which is wrap function. Now, the reason decorators are useful is because instead of doing this and frankly looking confusing, I can just add the @myDecorator, and we don't need to do all of this. Our hello gets automatically wrapped by my decorator. But essentially, this is what the @ sign is doing. See? Nothing magic about it. Now, right now, this is nice, but I bet you're still wondering why decorators are useful. So in order to really finalize our understanding of decorators, let's take a break and I'll see you in the next video. Let me ask you a question. What happens if this hello function actually took a parameter? Let's say a string or a greeting. And a greeting was going to be printed here. Let's remove the by for now. Would this still work if I run hello? Pause the video and think about it. Let's find out. Nope, that's an error. If you can, try to pause the video here and see if you can solve this. How can we make this allow arguments? I see that on line 5, right here, it says line 5. Hello is missing one required positional argument, greeting. Because when we actually call hello, we're expecting to have a parameter, but here we're not giving it any arguments. How can we solve this? Well, the one way is to just simply say greeting, right? Or we can say whatever we want. We can say X. And then this wrapper function receives the parameter. So that if I click run, line 13 is now giving me an error because, well, now we need to actually give it a greeting. So let's say hi. If I click run, all right, this works. And I hope this makes sense, right? We're calling hello with hi. So this function, hello, gets passed. We then receive as argument the X, right? Remember, underneath the hood, my decorator is saying A equals my decorator and hello, right? So all we're doing is running my decorator hello, which now turns into the wrapped function. And when we do the wrapped function A, we give it an argument of hi. So the wrapped function accepts this parameter and then runs the function hello. But here's the question. What if greeting also had an emoji that it accepts? So we're printing greeting and then the emoji. What do we do? Well, again, we'd have to create another parameter and then another parameter and then here call it with, let's say, a smiley face. If I click run, well, this should be a string. If I click run, this works. But this is hectic. Every time I need to change parameters, well, I have to modify this. And what if we had keyword arguments like default hi? There's actually a pattern here that we can use that makes things really, really simple for us. And all we do is this. we do the star args, which we have seen, which takes all positional arguments, and then star star keyword args, which takes all the keyword arguments. And we call the function by saying star args to unpack all the positional arguments, and star star keyword args to unpack all the keyword arguments. Now, if this looks confusing, don't worry. This is just a pattern that you can just copy and paste and remember. But now, check this out. I can do emoji equals to, let's say, sad face as the keyword argument. And now, if I just pass hi, like this, and hit run, and let's just remove this as well, since we don't need it. We'll call hello properly because we have the decorator, and then click run. Look at that. I get hi with the sad face. Now, the reason this is called a decorator, it's because it's a famous pattern in programming. It's called the decorator pattern. And this is the decorator pattern. It gives our decorator flexibility so that we're able to pass as many arguments as we want into our wrapped function by using star args and keyword args and then unpacking them like this inside of a function. And this syntax, let's say if we didn't even have the print statements, this syntax is why decorators are so powerful. By just using these lines of code, we're able to add functionality using the decorator pattern to decorate our functions. And the decorator patterns are used all over programming. So it's a very, very powerful concept. To finish off the lesson on decorator, I want to talk to you about some of the ways that decorators can be useful and some of the common locations that we're going to see decorator patterns in our code. And we're going to build our own performance decorator that's going to be able to tell us how our functions perform, how fast they are. And I promise you, by the end of that video, decorators are going to make sense to you. And you're going to be able to explain to other people and other friends why we should use decorators in our programs. I'll see you in that one. Bye-bye. So let's talk about some of the practical applications of decorators. I mean, we've already seen them in classes, right? We saw how class method and static method. We're able to create class methods and static methods on the class that the direct class can use. And if you don't remember these, just go back to those videos. But I want to show you one of my favorite examples of a decorator. We're going to create our own. What we're going to do is I want to have a performance decorator. And by the way, this decorator doesn't exist in Python. We're going to build it from scratch. What I want to do is be able to have a performance decorator that I can use during testing my code to see how fast my code runs. For example, if I had a function, let's say long time, that takes, well, a long time to complete. So I'm going to do a really long loop and say for I in range of, let's say, all these numbers, and I'm just going to do a random calculation, I times 5. This function, I want to know how well it performs, how many milliseconds it takes to complete this. So how can we build that? First, I'm going to do something that we haven't talked about yet that we will. Something about modules and built-in modules. So for now, we're not going to talk about this too much, but we're going to import from the time module something called, well, time. Again, something that we'll talk about in the module section of the course. I'm essentially saying, hey, when I installed Python, or in my case, when I'm using this REPL, it has access to this time if I ask for it. And in this case, I'm saying, hey, I want to use this time object or module that I get from Python. And in here, we're going to create our decorator following the pattern that we've learned. I'm going to say define performance. And performance is going to accept a function, just like we've seen before. And in here, we'll have our wrapper. So let's say wrapper function. And wrapper function, if you remember, it's going to be flexible by taking in star args and star star keyword args so that we can pass it however many parameters we want, because we don't know how this function, how many parameters it's going to have, and I want to be able to use performance on all my functions. Now in here, first, what we're going to do is we're going to have the result of the function be the function that we receive right here, and then simply say, run the function with star args and star star keyword args. And finally, at the end of this, I want to return the results. And then finally, we're going to return the wrapper. So nothing we haven't seen before. I could have just done return here or just ran the function, but I'll show you why I did it this way in a second. Right now, our function doesn't really do anything. If I click run, well, nothing happens. If I do long time and I run this function, it just took a long time to run, but that's it. Nothing happens. This is when we make things interesting. We want to calculate from the beginning of running this function to the end of running this function. And we can use time module to do this. I can create a variable, time1, for the start, and simply say time. So I'm running this time function. That's going to start a time and say, hey, this initial time is going to be t1. And after this function, our main function, long time, gets run, I'm going to say t2 and say, hey, what's the time right now? So this time, we'll check what time it's now, and then we're going to run this function, and then this time it's going to check the time. And however much difference there is between these two is how long this part took, right? So all we do is say print an f string and say it took t1 minus t2, right? And this actually returns in milliseconds, so I'll just say ms for milliseconds. And that's it. I've wrapped my function with just this extra time piece, and then I'm printing, as soon as we run the function, how long it took. So let's check it out. If I now run my long time function right here, and I click run, all right, I get a minus number because I messed up here. This should be t2 minus t1 because the time on t1, some time passes, and then t2. So t2 is always going to be larger than t1. If I run this, all right, it took 0.16 milliseconds. I think this is actually seconds. Now let's make this long function even longer. If I go like this and click run, oh boy, that took 1.9 seconds. What if I make it even longer? If I click run, and this is the part where I keep talking until the function runs because there's going to be an awkward silence. Otherwise, hopefully this ends soon because I have nothing else to talk about. Come on, this is getting awkward. All right, come on. Oh boy. I'm going to fast forward through here. Oh boy, it took 19 seconds. That's pretty bad. But I now have this decorator that I can give to pretty much any function in my program and actually measure the performance of my function. Pretty useful, right? I could have this piece of code, and before, let's say, I deploy my code or put my code out into the world, I can test how performant my functions are, and maybe I can optimize things in different ways. Very, very useful, and I did that in just a few lines of code, 9 lines of code. Now, mind you, this performance decorator depends on the machine and how fast your CPU and memory are on your computer. So for what took me 19 seconds might take you a lot more or a lot less, depending on your machine. but this is a nice way to compare functions relatively. So I hope after this you see the power of decorators. Decorators are used a lot in Python libraries and frameworks. Web frameworks that we're going to talk about, like Django and Flask, use decorators. Maybe you want to have some authentication decorator. So you do authenticated, where each function can only be run if the user is authenticated. Maybe they have the privilege to run a function, such as logging in to a website. Or maybe you just need a login or logging decorator that just logs and lets your database know that, hey, somebody has logged into your system, or hey, somebody has purchased something from Amazon, or hey, somebody just requested a friend request. There's so many uses for decorators. And decorator is a hard topic. You're not going to see them all over Python code. They're just an extra feature that you can use as you become more and more comfortable with Python. But I hope by the end of this all, you at least understand them to maybe one day build your own or use pre-built ones by libraries and frameworks. I'll see you in the next one.